Hey everybody, we have a modified competition problem. Now there's some given information, but you could actually make the determination without it being given. This last element in this succession of sets, 902, is actually equal to 82 times 11. Okay. 82 times 11 is equal to 902. And so you have this first multiple of 11, second multiple of 11, all the way down to the 82nd multiple of 11. So again, I could have given you this and not even mentioned the 82, but anyway, so the 82 is given. Now the question before us right here is how many of the sets contain exactly 2 multiples of 8? All right, how many of the sets, there's 82 of these sets, contain exactly 2 multiples of 8? Now let's just make a few observations. You'll notice right here that there would be one multiple of 8, namely 8 itself is in this set, right? It's right there in the ellipsis, right? So there's one right here, one multiple of 8. I'll just write down 1. It's clear the context we're talking about multiple of 8. Right here, let's see, 16 would be somewhere between 14 and 21. And you have no other multiples of 8, so you have one multiple of 8 here. Okay, let's go down to the third set, excuse me. Notice that 24 is a multiple of 8, namely 3 times 5. So 24 is a multiple of 8 contained in this third set, as is 32, which is a multiple of 8. It's 4 times 8, right? So there's actually 2 multiples of 8. Now, a conclusion that we can make is none of these sets is ever going to have more than 2, and I won't try to prove that. That's fairly self-evident. You know, the size of each set is 11. Multiples of 8 would be spread out to where you couldn't have 11 consecutive numbers with 3 multiples of 8 or multiples of 7 for that matter. But in any event, so we can make the claim that all of these sets, all 82 of these sets, either have 1 multiple of 8 or 2 multiples of 8. And I'll just say that, I won't write it down. All of these sets, all of these 82 sets contain either 1 or 2 multiples of 8. So the question becomes how many, or the question is how many of the sets contain exactly 2 multiples of 8? All right, let's move along. Now, a way to determine multiples is this floor function. You can just figure it out, common sense. But if you believe in the floor function, let me just give you a concrete example here. What if, let's say we wanted to do the floor of 19 over 8. Just keep the number small so you see the pattern here. So 19 over 8 is a number between 2 and 3, right? Since 24 over 8 is 3 and 16 over 8 is 2, 19 over 8 is a number between 2 and 3. That means the floor of 19 over 8 is equal to 2, right? But notice that actually is a counting function because we actually note that 8 and 16 are both multiples of 8 and they're less than 19, right? So this particular function counts the number of multiples of 8, all right? So in that same spirit here, 902, that we're talking about 902 numbers. We have these 82 sets that are disjoint, and their union is the integers 1 through 902 inclusive. And so what we know is that there's 112 multiples of 8 if you just, for the integers 1 through 902. Okay, so back to our question. We want to know how many of the sets contain exactly 2, all right? Well, notice that we have 82 sets, so let's just take a look here. We have 82 sets, and let me just, I guess we'll write here, if all 82 of the sets just contain 1, which we know is impossible, okay, that would give us, that would imply 82, right? Okay, there would be 82 multiples of 8, but we know that we have more than that from this information right here. So you see what we can conclude right here is there's going to be the difference between 112 and 82 will necessarily be the number of 2 element sets. So 112 minus 82, what is that, 30? So that means there has to be 32 element sets, because if you think of like the pigeonhole principle, those numbers have to go somewhere, right? So that means there's another 30 sets. That means exactly 30 sets will contain 2 elements, right? Okay, and exactly 50 sets, even though they didn't ask for that, would contain 1 element. And again, I'll write that down just if this isn't making any sense. What we concluded right here is there's 30, and this would be the answer, 32 30 sets with exactly 2 multiples of 8. Okay, I'll leave out exactly, just so I have to write it. With exactly 2 multiples of 8. Of 8. Okay, now that's the answer to the question. Now, if you don't believe that, just note that there's 82 total sets, right? So you would have, if you want to account for all the multiples of 8, you would have 30 times 2. Okay. 30 times 2, right? 30 sets with 2 multiples of 8, so that would be 60. Plus, how many do we have left from 30? That would be 52. But each of those 52 just contain 1 multiple of 8, right? But notice, what do we get there? We should get 60 plus 52, which is the 112 multiples that we had to account for. Okay, so you see how this 112 and this 112 line up. And I think this is an application of the pigeonhole principle, somehow or another, without identifying the pigeonholes and blah, blah, blah. But I think the pigeonhole principle applies here, but you don't really have to be too formal about it. But in any event, this is the answer to the question right here. There's 30 sets. There's 30 sets with exactly 2 multiples of 8. And let me run up here and write that. Yeah, let's just answer it right here. The answer would be, since I've circled more than one thing, 30 of the sets contain exactly 2 multiples of 2. Thank you for viewing.